If you track the DNA of the modern world, the factory lines, the cities built around industry, the very concept of reliable, massive power, it all leads back to a single invention.
And to one deeply curious mind who became obsessed with inefficiency.
We're diving into the life and inventions of James Watt, the Scottish engineer who didn't just improve the steam engine.
No, he fundamentally redesigned it. He took a clumsy, expensive machine and turned it into the central engine of the Industrial Revolution, making massive power available to everyone for the first time.
So let's start with Watt himself. He was born in Scotland, Greenock, in 1736.
And he was often quite ill as a child, which actually turned out to be a bit of a blessing in disguise.
How so?
Well, it meant he spent less time outside and more time inside with books, specifically about mathematics and how complex devices worked. He developed a meticulous eye for detail.
And that detail-oriented mindset was everything.
It was key. He trained as a scientific instrument maker, a very specialized trade, creating precise tools like compasses and scales. He eventually got a position as the instrument maker for the University of Glasgow.
Which was a crucial turning point.
The huge one, because it gave him access to all the latest scientific thinking and, maybe more importantly, a steady stream of machines that were constantly breaking down.
And one of those machines was a little model of the biggest industrial tool of the day, the Newcomen steam engine.
Right. The Newcomen engine was a marvel for its time, but it really only did one thing.
Pump water.
That's it. It pumped water out of Britain's deep coal mines. Without it, the mines would flood and the fuel supply for early industry would have just collapsed. It kept miners safe and the coal coming.
But when Watt was asked to repair this little model, he didn't just fix it. He looked at the whole design and saw something staggering.
A colossal amount of waste. He basically saw it as a thermodynamic disaster.
So what was the problem? What was so wasteful about it?
Okay, so this is the core of it. The Newcomen engine worked by condensing steam inside a huge metal cylinder. To do that, it first had to heat that cylinder with steam.
Right.
And then, in the very next moment, it had to spray cold water directly inside that same cylinder to cool it all down and create a vacuum.
Wait, so you're heating this massive piece of metal up.
And then immediately pouring cold water all over it.
It's like trying to boil water in a pot while someone's pouring ice water over the outside.
That's a perfect analogy. The vast majority of the fuel, maybe 3/4 of the coal being burned, was just wasted reheating the metal cylinder for the next stroke. It wasn't actually doing any work.
So for a mine owner, that's just a huge, huge fuel bill.
Exactly. It was incredibly expensive to run.
So Watt knew he had to solve this heat problem. And the solution, it came to him during a walk in a park in 1765.
And it was one of those beautifully simple aha moments. The solution was you have to keep the main cylinder hot all the time.
But how? You still need to condense the steam.
His innovation was the separate condenser.
A separate condenser, so different chamber.
A totally new, separate chamber connected to the main cylinder. So after the steam pushed the piston up, instead of being doused with cold water, it was shunted into this other chamber.
And that new chamber was the one that was kept cold.
That's it. It did the condensing, creating the vacuum. But the main engine cylinder, the big, expensive part, stayed blazing hot, ready for the next shot of steam.
That's revolutionary. It means the engine is always at the perfect temperature.
Right. So it could work much faster, continuously, and the fuel savings were enormous. It went from being this marginal, expensive machine to a truly viable power source.
But going from a working model to a giant commercial machine is a huge leap. Watt was a brilliant engineer, but he wasn't a businessman.
Not at all. He needed money, a factory, he needed help, and that's where Matthew Boulton comes in.
The famous partnership.
Right. Boulton was a wealthy industrialist in Birmingham. He had the factory, the funding, and the commercial vision. It was the perfect match.
Boulton famously said he was selling what all the world desires to have, power.
And he was great at it. Boulton handled the sales and contracts, while Watt just obsessed over perfecting the engineering. Their factory became, the Silicon Valley of its time.
But even with this more efficient design, their first engines still had a big limitation.
They did. They only moved straight up and down, which is fine for a water pump.
But not for a factory. To run a loom or a mill, you need things to turn. You need rotary motion.
And you'd think the obvious answer is to just attach a crank, right, like on a bicycle pedal.
But he couldn't do that.
Nope. The simple crank was already patented by a rival. Watt refused to pay a licensing fee, so he had to invent his way around the problem.
So he had to invent a whole new way to get circular motion.
Exactly. He came up with the sun and planet gear. It's a system where one gear, The planet revolves around a central gear, the sun.
Yeah.
It was this brilliant, slightly complex system that smoothly converted the up and down movement into a turning motion.
And that was a colossal breakthrough.
Huge, because once the engines could turn a wheel, you could connect them with belts and pulleys to every machine in a factory. Before this, you had to build your factory next to a river for a water wheel.
Now you could build one anywhere you could get coal.
Power became portable. And that's what allowed massive industrial cities like Manchester to just explode into existence.
Okay, so you have this universal power source, but now you have a sales problem. How do you explain its power to a customer who's used to, well, horses?
He needed a common language, a unit of measurement. And that is why he invented the term we still use every day, horsepower.
Horsepower.
Yep, or HP. He actually studied horses at a brewery and calculated how much a strong horse could lift in a minute.
What was the number he came up with?
He figured a horse could pull 33,000 pounds a distance of 1 foot in 60 seconds. He defined that as 1 horsepower.
So when they sold a 10 HP engine, the customer knew exactly what they were getting.
They were getting the work of 10 strong horses continuously without getting tired. It was a marketing masterstroke.
It's amazing that we still rate our cars with a unit that came from an 18th century sales pitch.
It is, but it wasn't just about raw power. A factory engine also needs to be consistent. If it runs too fast, it could break the equipment. Too slow, and you lose efficiency.
And in the early days, you needed a person just standing there,
Right.
manually adjusting the steam valve.
Constantly. A really boring job and very prone to error. You couldn't scale a factory that way.
So Watt needed to automate speed control.
Which led to one of his most elegant inventions, the centrifugal governor. This thing introduced the whole concept of an automatic feedback loop to engineering.
How did it work?
It's actually quite clever. It had 2 heavy metal balls on arms spinning around a spindle that was driven by the engine itself.
Okay.
If the engine started to speed up, centrifugal force would make the balls fly outward and upward.
And that movement did something.
It did. The arms were connected to the steam valve. As the balls flew out, they automatically closed the valve a little, letting in less steam and slowing the engine down.
And if it slowed down, the balls would drop and open the valve more.
Precisely. It's the very first form of industrial cruise control, a system that regulates itself without a human. That basic idea is still in everything from your thermostat at home to modern robotics.
That stability was the final piece of the puzzle.
It was. Once you had an efficient, rotative, and self-regulating engine, the Industrial Revolution could truly hit full speed.
And the first industry to be completely transformed was textiles, making cloth.
Absolutely. Before Watt, cloth was made slowly by hand or in small mills by a river. With these engines, you could build massive textile mills in cities, running hundreds of spinning machines, 247.
And the amount of cloth they produced just exploded.
It did, which dramatically lowered the price of clothing. For the first time, quality clothes became affordable for the average person.
But it also transformed society itself.
Completely. Thousands of people moved from the countryside into these new, dense industrial cities to work in the factories. It created the modern urban working class.
And even though Watt mostly focused on these stationary factory engines,
His principles were the foundation for everything that came next in transportation. The efficiency, the rotary motion, that's what made steam locomotives and steamships possible.
it literally changed how fast the world could move.
People and goods could cross continents and oceans faster than ever before. Watt's engines set a new speed limit for the entire world.
Now, inventing this stuff is one thing, building it is another. I imagine making these engines was a huge challenge.
A constant headache. That separate condenser only works if the cylinders are perfectly round and airtight. And 18th century metalworking just wasn't that precise. His first engines leaked steam all the time.
So how did he solve that?
He got help from another inventor, an iron master named John Wilkinson.
Wilkinson.
Wilkinson had just invented a new machine for boring out cannon barrels with incredible accuracy. Watt realized that a machine that could bore a perfect cannon could also bore a perfect engine cylinder.
So military technology helped drive industrial technology.
It was that synergy, that connection, that made it all work. Watt's design needed Wilkinson's manufacturing breakthrough to be reliable.
And on top of the technical problems, he was also fighting legal battles to protect his patents.
Constantly. But in the end, the Boulton and Watt engines just won out because they were so much better and so much more efficient than anything else. He retired a very wealthy and famous man.
And his greatest honor is that his name is now the literal unit of power, the watt. We use it for everything from light bulbs to power grids.
But we do have to talk about the flip side of all this success.
The environmental cost.
Right. Watt's engine was more efficient, but because so many were built, the overall demand for coal skyrocketed. And all these factories now in the middle of cities started pumping out smoke and soot.
So the efficiency gains were kind of canceled out by the sheer scale of it all.
For the first time, human industry was having this massive, visible impact on the environment of entire cities. It was the trade-off. Cheap, reliable power at the cost of clear skies.
So to wrap up, here's a final thought for you to consider. James Watt's great achievement wasn't just building an engine. It was creating a reliable, self-regulating, scalable power system. That push for efficiency and automation, which started with his little spinning governor, now defines our modern world of AI and robotics. The question isn't whether automation works. Watt proved that centuries ago. The question is, what new jobs and what new societal changes will this next generation of power unlock?
James Watt didn't just invent a machine, he invented the modern idea of industrial power. Good luck with your studies.